There are moments in technology when the ground feels as if it shifts quietly beneath your feet long before the world admits anything has changed. A whisper becomes a tremor. A small rumor turns into a pulse, and then suddenly a number appears. A number so unreal, so strangely out of place that it feels like a glitch inside the system. 10,955. You hear it once, and it just sticks somewhere in your mind. A price that should not exist. A price that almost reads like a typing mistake in a world where electric vehicles have drifted into a territory reserved for glossy showrooms and carefully polished dreams. But this number refuses to act like a gimmick. It stays. It stirs doubts. It invites curiosity. It challenges every assumption. It makes you wonder whether someone out there is quietly rewriting the rules while the rest of the industry is still busy rewriting presentation slides. And with whispers of a Tesla Model 2 prototype floating through the internet like a ghost, the real reveal may not be a shape, or a teaser silhouette, or a dramatic specifications list. It might be something far more rebellious, a philosophy, a way of removing cost without removing dignity, comfort, or emotional experience. A way of calculating ownership that never appears in brochures but silently reshapes the long life of a car. Before we go deeper, let me ask you something in a simple and honest way. If you love cinematic engineering stories told with clarity and mystery, tap subscribe to Auto Intel right now. Not later, not someday, right now. Because the chapters coming after this one are already taking form. Because when the name Elon Musk enters any conversation, the surprise rarely comes from one direction. Is the shocking part the materials, the extreme production method, the confidence to aim lower in price while staying high in experience? Or is it the quiet certainty that Tesla will break rules even when no one is requesting them to? The truth is, the real shock might not be the moment your hand touches the door handle. It might be the months of ownership that feels smoother, cooler, quieter, and unexpectedly cheaper. If you are someone who enjoys deep engineering journeys like this, stay with Auto Intel, because this is only the beginning. Now the story shifts. The first question arrives not as a title, but as momentum. Which choices inside the Model 2 cut weight, reduce heat, and still protect that premium cabin feeling? It begins with something almost invisible, a roof, a piece of material most people never think about, yet it defines a huge portion of the emotional experience of being inside a car. The Model 2 introduces a prismatic polycarbonate roof, not as a gimmick or a cost-cutting shortcut, but as a deliberate engineering method that tackles cost and performance at the same time. Polycarbonate has a density of roughly 1.2 grams per cubic centimeter, while tempered glass sits closer to 2.4 or even 2.6. Swap a heavy panoramic sheet with a single thermoformed polycarbonate panel, and the material cost plus processing drops by around 60 to 70%. But cost is only one side. Weight is the part that transforms the physics of an electric car. Removing 12 to 18 kilograms from the highest point of a small vehicle may look minor on a spec sheet, but weight at the top is not just weight. It is leverage. It influences pitch and roll. It changes how traction systems respond to tiny motions during city driving. Even a modest 1 to 2% improvement in efficiency inside stop-and-go traffic becomes meaningful when the entire car is designed around a compact battery pack. The heat reduction is just as important. Tesla treats the polycarbonate with two layers. One blocks almost all ultraviolet rays. The other filters infrared radiation with around 80 to 85% strength. Under harsh sunlight, these layers keep the cabin roughly 4 to 6 degrees Celsius cooler than a standard glass roof. That difference shifts everything. A cooler interior means lower air conditioning demand. Lower cooling demand means better driving range. Better range on a small battery means a more forgiving, less stressful lifestyle for buyers who may leave their car outdoors every day or take short trips repeatedly. Initial cabin cooldown alone can save around 5 to 7% electrical energy during the first hour. These are the quiet savings that accumulate month after month without drawing attention. Production fits smoothly into Tesla's broader philosophy of speed, simplicity, and easy repair. Thermoforming a polycarbonate sheet can take less than 90 seconds. Repairing damage costs around $180, including labor. A panoramic glass roof can demand $800 to over $1,000. That difference changes how people behave with their car. A broken roof becomes a small inconvenience instead of a financial wound. And yet, the roof does not look cheap. Polycarbonate allows for prismatic microstructures that bend light softly, giving a diffused, natural glow inside the cabin. No harsh reflections, no strange color tinting, just a clean, airy, premium feeling created through physics rather than price. From cost to weight to heat control to aesthetics, this roof becomes a small miracle of purpose, a perfect demonstration of the Model 2 philosophy. If you would pick this lighter roof that saves 60 to 70% of cost and keeps you 4 to 6 degrees cooler, drop a yes in the comments. Then the story moves forward. Long trips, hours behind the wheel. The moment when comfort stops being a luxury feature and becomes something essential. Tesla's motorless air cell seat system inside the Model 2 is a paradox. It looks extremely simple, almost too simple. Thin air chambers placed in the back section and thigh area, a lightweight microblower, around 200 grams, a pressure cavity, and a set of tiny solenoid valves. No motors, no complex gears, no vibrating modules. But this simplicity is not an accident. It is surgical, a way to deliver a premium physical experience while removing the usual disadvantages of motor-based massage seats. The air cell system draws around 8 watts. Traditional multi-motor seats draw 40 to 60. On a long 3-hour drive, that difference becomes around 0.1 to 0.2 kilowatt hours. It sounds tiny, yet tiny slices of saved energy multiplied over months and years turn into meaningful range. Weight tells the same truth. Classic motor systems weigh 2 to 3 kilograms each. Removing them cuts 4 to 6 kilograms from the front seats alone. That is around 0.3 to 0.5% of total mass val. Because this weight sits low, it improves roll stability during lane changes and slow corners. What matters even more is the sensation for the person sitting there. The air cells inflate and shrink gently in cycles between 20 and 40 millimeters of mercury. Pressure changes subtly. Microcirculation improves. Numbness slows. Back fatigue drops by 15 to 20% based on reports from long-distance drivers. In hot and humid climates, microventilation inside the seat material keeps the back dry. The blower remains below 30 decibels, basically silent inside a closed cabin. Durability makes the difference even sharper. Removing motors drops moving parts by around 70%. Microblowers have an average lifespan above 20,000 hours. Maintenance is little more than brushing a dust mesh occasionally. Replacement cost around $35 per seat. Compare that to $200 or $300 for repairing conventional massage modules. Tesla gives the premium feel without the fragile complexity. As the ride continues, you reach one of the most emotional touch points of any vehicle: the sound of the door closing. Luxury cars rely on soft close systems, motorized latches that pull the door shut in the final millimeters. They're elegant. They are expensive. $300 to $400 per door. Heavy, complex, delicate. The Model 2 chooses something different. Simple yet refined. Dual-stage air gaskets. Alignment magnets that nudge the door toward perfect positioning. The final few millimeters compress smoothly with a soft, controlled curve. The magnets guide the edge with precision. The result is a gentle, cushioned, quiet sensation. The force required lands around 30 to 35 newtons. Many mass-market cars need almost double. In the 1 to 2 kHz band where cheap doors snap sharply,
The Model 2 cuts noise by around 1.5 to 2 decibels. A tiny number on paper, but a big difference in how it feels. At highway speeds around 110 kilometers per hour, the same sealing method reduces cabin noise by about 1 to 1.5 decibels. Leakage airflow drops 20 to 25%. Air conditioning loses less cool air, energy usage dips by around 3% at speed, and the cost is around $12 to $15 per door, roughly 30 times cheaper than soft-close systems, 2 to 3 kilograms lighter. A pure example of doing more by doing less. Night arrives and the interior lights activate, but not with pixelated strips pretending to be premium. Tesla uses one 3-watt RGB light source, sending illumination through 6 to 10 meters of optical fiber routed around the dashboard and doors. The effect is a continuous ribbon of light, smooth and elegant.